Welcome to the IT Fundamentals Training Series. This is Chapter 1, Episode 13. Lucky 13. And we're going to finally get to hard drives. Now, this is going to be a multiple episode scenario here, but we're going to get started with hard drives. Join me. Here we go. Welcome back to IT Fundamentals, Chapter 1, Episode 13. Episode 13, we're going to talk about hard drives. Now, you all are probably familiar with solid state drives, because that's pretty much what is common these days, are solid state drives, although you can still buy hard drives that are spinning disks, that are magnetic disks. But most folks are familiar with solid state drives, and we will talk about solid state drives in episode 14, other than just a quick introduction. But what we need to do for the purposes of IT Fundamentals Plus, and because you still will run into these types of disks, especially in servers and especially in some of the older computers, if you were to start a IT career today, we need to talk about multiple types of hard drives. In fact, we need to talk about other storage drives other than hard drives as well. So let's get going here, and let's talk about overall exploring storage and expansion and devices. And we've talked about RAM, and that's a storage device, volatile versus non-volatile memory. And what we're talking about when we talk about a hard drive is typically a non-volatile memory. We've gone over that before, where that means it's there permanently. You shut the computer down, you remove power, you can actually remove the hard drive itself and move it from one computer to the other. So hard drives are large storage capacity drives, and inside of servers, even inside the cloud today, solid state drives are still rather expensive for large capacities, and so spinning disk drives are still what's used very frequently out there. Now, spinning disk drives, you have them running at multiple different types of speeds, and they are also retrieving the data off of them is faster with the higher platter speeds. So let's just kind of dive into a little bit about what a hard drive, a spinning disk hard drive, might look like if you were to have it in your hand. All right, so first of all, if you have one in hand, they're going to be usually fairly decent size devices. So, they come in the size maybe of an iPhone these days, but they used to come in being 2-3 times the size of an iPhone, both on thickness as well as in width and other measurements on there. Inside of a case, a sealed case, is a spinning disk, or sometimes multiple spinning disks, what we call platters. And those are spinning disks that are magnetic. And what happens is that the data is placed magnetically on those drives by a needle, literally a needle that is writing the ones and zeros on that drive. And that is how storage has been for many, many years, until the solid state or SSD drives came out. And what we used to do in teaching this, and you still may be familiar with this because I know they've kind of made a comeback in the past few years, but if you remember the old records that people my age were the only way we could listen to music back in the day was on these records in the 50s, 60s, and 70s, and they would turn on a turntable, and they would have a needle that you place down on top of it. That's a smaller version of that, is generally what a hard drive looks like. Now, you'll notice I said inside a sealed case. Now, these hard drives need to be protected from dust, dirt, and grease. And so what they do in manufacturing is they will create the top and the bottom case. They will place the drives inside them, inside of what's called a clean room, meaning that the room is sterilized, probably even more so than an operating room in a hospital. The people that are doing placement of these drives, if they're not manufactured through automation and robots, the people will be wearing what would look like spacesuits or clean suits, top to bottom, masks on, everything. They would have gloves on, and they would place these platters inside of the cases and then seal the cases. There would be a rubber seal inside of it, so as they use screws to screw down the top to the bottom piece of the case, that rubber would get squished and seal that. Now, that's the old style. They've obviously replaced a lot of that with automated operations that do that, but they still do it in a clean room, because any dust, dirt, grease that gets on those will completely ruin the discs. So my advice is never open one of those up unless you're intending to never use that disc again. Now, on top of all those pieces that I just talked to you about, you might be asking, okay, how do I interface that with the computer? And that's a great question, because how do you take that spinning disc and that needle and somehow get that connected to the computer? And you may have recalled when we talked about IDE and SATA cables in previous conversations talking about the motherboard. Well, what you would do is there's a chip or a circuit board that's placed onto the hard drive case, on the exterior of the hard drive case, that has interfaces, much like with your DIMMs and SODIMMs, those bus connectors that are the little gold connectors. They will connect to the similar types of interfaces on the case. You'll put that circuit board onto the case, and then that circuit board has either the IDE or the SATA connection to it in order for you to connect it back to the motherboard. So that's how you get the data from the hard drive through the case that's supposedly sealed on, and then over into the motherboard in order for it to be processed. So that's a high level understanding of the hard drives. Now, what you need to understand for the test is you actually do need to understand those IDE drives. In fact, a picture of these disks, multiple disks, 3 disks, and the needle is figure 1.20 on page 34 of your book. So you do need to know that information that I just shared with you. And you also need to understand, again, acronyms that are important here. So HDD is an acronym that you'll need to understand. That stands for hard disk drive. And a lot of people just call it HD, or they call it a disk drive or hard disk. And so you need to know that acronym when you're taking the test. You also need to understand and know that the platters are metal or glass platters that are coated with a magnetic coating, because when the needle writes to the disk, it's using magnetism in order to write the ones and zeros onto the disk, and the ones and zeros being that binary data. So those are some important pieces that you have to look at. Now, looking at hard drive characteristics on page 35, these are some informational pieces that you need to understand as well in table 1.2. And just understanding, we had talked about this a little bit when we were dealing with RAM and other types of functions, how to essentially count bits and bytes. And this is a bit and byte conversion table. You really don't need to know bits, 1 bit to 1 bit. You need to know that 8 bits is 1 byte, but you need to start paying attention when we go from 1,000 kilobits equals 1 megabyte, and 1,000 megabytes equals 1 gigabyte, and 1,000 gigabytes equals a terabyte. So if you're looking at table 1.2 for the test purposes, take your magic little pen and go to where it says, let's just go with 1,000 bytes equals 1 kilobyte, and put a line above that. Go down to 1,000 gigabytes equals 1 terabyte, put a line underneath that one, and then draw a line between the two. That's the information that you need to learn. Those conversions, if you will, are what you need to learn for the test, because those are the ones that are going to be important. Now, under the notes section on page 35, it also talks about other types of disk drives, okay? 3.5 and 5.25 disk drives that are 1.44 and 1.2 megabytes. Don't worry about that information for the test. Okay. This is back, way back in the olden days when we had hard drives, but we also needed to be mobile with some of our data. And so we would have, in essence, these little bitty, very physically, they were very large, but capacity wise, they were these little bitty magnetic drives that we could walk around with and move from one computer to the other. This is even before the days of networking or reliable networking, I should say. It's before the days of solid state drives or USB drives that had some non-volatile type of memory that you can run around with. All right. So that's an overview of those pieces. Now, the next thing you need to pay attention to is on page 36. Down towards kind of just below the halfway point, you see where it's got some bullet points. It starts with 5,400 RPM and goes up to 15,000 RPM. All right, those platters inside of the spinning disk hard drives are spinning at a rate of, guess what, 5,400 revs per minute. So literally, if you were to draw a line on one of those disks from the inside to the outside, draw a line there, and you count every single time that line went by the needle, that device or that disk is spinning 5,400 times per minute. So every 60 seconds, it's gone around the sun, so to speak. It's gone around through its needle 5,400 times. Now, 5,400 is a very slow disk. And so you may have an enormous amount of RAM. You may have a great processor, but this is another thing that really slows down the computer, where the SSDs or the solid state drives that we'll talk about in later episodes. I believe we'll talk about it in episode 14. You don't have spinning disks, so you don't have to worry about those RPMs and dealing with that. And so the data comes off the SSDs very quickly. But on the spinning disks, the data comes off of that as related to the RPM. Now, back in the day when these spinning disks were the thing that were in computers, in fact, if you buy a gaming machine right now, your primary disk, like maybe 1 terabyte of disk space, will be a solid state drive, and the secondary drive would be one of these spinning disks because they remain very cheap. But more than likely, what you're looking at with one of these spinning disks, even in a modern computer, is a very slow 54 or 7,200 RPM spin. And that's because those are even cheaper to produce. So a lot of people go into Best Buy or they go into Walmart or wherever they buy their computer from, and they're getting, oh, look, I've got a 1 terabyte SSD, and then I've got a 4 terabyte hard drive, and they fail to look at how fast that second drive is spinning, and then they wonder why it takes so long to get their pictures up off of the computer and onto the screen, or it takes so long to get certain data files that are on the spinning disk up onto the computer. Well, it's probably because of the spin rate and not your computer itself. Typically a 10,000 RPM disk is first of all, it's going to cost you a significant amount more than the 7,200 RPM, but it's going to be where you're going to be very your modern computer is going to be more than sufficient at 10,000 RPM. In fact, I don't know that I've seen a 12,000 or a 15,000 RPM drive, even in servers that we have in the cloud. Most of them are 10,000 RPM drives. So I would never buy a 5,400 RPM unless I intended to replace that disk inside of my computer. I might buy a 7,200 RPM drive if the only thing I'm doing is placing pictures or other types of data on it where I'm not going to access it frequently. I would likely use a 10,000 RPM drive. So keep that in mind as you're going through this testing process as well, that that is for the number of revs per minute, number of times it's going around and around and around, and then the number as it increases actually indicates the speed in which the needle can read the information off of the drive and get it to you. So those are some important pieces. Now, as we begin to look at wrapping things up here, I want to talk about how, we talked about and described a few moments ago the connection between the hard drive to the motherboard, and that's on page 36, 37, and 38. All right. So it's talking about three key types of cables, if you will, that get the data between the connect the hard drive to the motherboard. First of all is the integrated drive electronics, or IDE cable. Now, figure 1.21 actually has an IDE drive, a PATA IDE drive stacked on top of a SATA drive. And if you look very closely, and I know some of these diagrams or some of these photos inside this book are a little bit hard to see because they're smaller, and more so because they're black and white. But if you look very closely, the drive that's on top is an IDE drive, and you can see there's a whole bunch of pins in there. And those are the old-fashioned pins that I've talked about before, where if you bend one of those, you're toast. So on the left are those IDE pins, and on the right is the power cable that goes in there. Now, those are bigger pins that you really can't break very easily. But in between those is a very important piece that the SATA drives do not have, okay? And those pins in there, there's 1, 2, 3, 4, there's five rows of pins in there. And you'll notice that one of them has a white block over it. Now, that white block is called a jumper. And that jumper is literally a piece of plastic that has metal looped into it that you pull out and you place it on those various pins, depending on whether you want the drive to be your primary drive, a secondary drive, tertiary drive, which means a third drive, and so on and so forth. So you have to know how to do jumpers if you're using these IDE drives as well, because if you don't put the jumper on correctly, let's say you put that jumper on, instead of in that first position, you put it in the third position, and then you try to boot off of that drive, it will fail to boot because the motherboard will not recognize it as a boot device. Okay, modern systems, you don't have to use those jumpers. They figure that kind of thing out themselves. So if you look at the second drive that's underneath there, you'll notice that essentially the only thing you have is a power connector and also the data connection. There are jumper items there, but you never use them. It just automatically handles that itself. So you're looking at the IDE drive, and then you're looking at a parallel ATA or PATA, which is also the IDE drive. So when I said earlier we have 3 different type of connectors, you need to know that for the test that you have 3 different type of connectors. But the parallel, or PATA, the parallel ATA is exactly the same. There's no difference except for the name as the integrated drive electronics, the IDE. Here's the difference between the two. When they came out with the SATA, which is a serial ATA, they decided to retrofit that name onto the old IDE so that you understand the difference between the two more easily. So they kind of made them synchronized, if you will, to some degree. Both ATAs, one's a parallel and one's a serial. And but again, the parallel ATA and the IDE are the same type of connection. All right. So the serial ATA goes with a more modern type of connection where you're using the pins, kind of like what's on your memory, your DIMM modules, where they're not the stick up pins like you see on the IDE that can get bent and are, could be problems, but they're more connectors that rub together or come together and are easier to maintain and also easier to clean if it's necessary to do so. So that SATA technology came out in 2003, and it really did revolutionize the computer systems that were there at the time. It also allowed us to create smaller drives as a result of that. And so those are the things that you need to know for the upcoming test. There is a figure 1.22 on page 38 that shows you a picture of the PATA or the IDE cable, and you can see how large that is and how broad that is. And then the SATA cable that's underneath that, you can see how much smaller it is, and actually how much more robust it is as well. All right, so when we come back tomorrow, we'll talk about the SATA drives, or I'm sorry, the solid state drives, not the SATA drives, the solid state drives. But just as a reminder for today, knowing the difference between the PATA and the SATA, or knowing that PATA and IDE are synonymous, knowing that you probably will not see an IDE drive right now, but you will see spinning disk hard drives versus solid state drives, and understanding that the spinning disk drives are magnetic, and the spin goes at a rate of 5,400, 7,200, 10,000, 12,000, or 15,000 revolutions or revs per minute. And that the smaller the number means the slower the data comes off of the computer. Those are some key factors that you need to look at today in understanding the test. Now, that should get us through, and so that we could talk about solid state drives tomorrow. I look forward to bringing that to your attention. Again, we want you to bring in your questions and bring up the things that you're not understanding, and I hope that everybody is understanding this. At this point, is pretty basic data. We went over a couple of things that were a little cumbersome a couple of episodes ago, but if you do have questions, please email me, mhoupt@commonsensesecurity.net, and I will be happy to help you try and figure those out. All right. Go ahead and go back to your book, take a look at it, reread that, and make sure you understand everything. We'll talk to you later. Thanks.